And hello, AP Physics students. Mr. Kirsten coming at you here. Going to be talking about kinematics in one dimension today, our second lecture and homework example problem of the year. We're going to be checking out problem 16 and short little lecture first here. So kinematics, what is kinematics? Kinematics is the study of motion without regards to the causes of the motion. So we might say a car is accelerating, but we're not going to talk about why is it accelerating. We won't get into forces and reasons for acceleration until we get into dynamics in chapter 4 and 5. And motion in one dimension is just saying the object is going up or it's going down or it's going left or it's going right. But it's not going up and right simultaneously. So just moving in one dimension. So make sure you do your reading for tonight. Make sure you can distinguish between terms like distance and displacement. Distance is the total length of travel, whereas displacement is your final position minus your end position. For instance, on the track, if I tell a runner to run one lap, exactly one lap, the distance they've run would be 400 meters, but the displacement would be 0 meters, because if you start and end at the same spot, your displacement would be 0. And make sure you can distinguish between average speed and average velocity. Average speed is distance divided by time, whereas velocity is displacement over time. Okay, and also talk about be able to differentiate between instantaneous velocity and average velocity. Average velocity is your displacement over time for some time interval, where instantaneous velocity might be like the slope at a point on a position versus time graph, or your velocity over an infinitesimally small amount of time. Okay, and our problem today is going to talk about acceleration. So make sure you do your reading, understand those terms. I think there are terms you've probably seen before in math classes or in other science classes. And then we're going to do problem 16 using the 5 problem solving steps. So we're going to detail those for you. Okay, let's dive into our problems here. Problem 16 states that I have a car and it accelerates from 0 to 95 kilometers per hour in 6.2 seconds. What is the average acceleration? And to solve this problem, I'm going to use the 5 problem solving steps. Step 1, I'm going to draw just a little diagram here. So here's my diagram. I'm going to define a coordinate system here. So to the right here is going to be positive direction. I'm going to draw a car, very fancy car that I'm drawing here. Ooh, this looks really fast. I'll bet you this is like one of those super fast electric cars or something. Looks good. Okay, so I've got a diagram. I kind of know what's going on. All right, check. Step 1. Step 2, define any variables that you know about from the problem. Well, it says the car starts from rest, so my initial velocity, or v1, is going to be 0. And it says the car gets up to 95 kilometers per hour. So v2 is going to be 95 kilometers per hour. It says it takes 6.2 seconds for this to happen. So I can define a T1 and a T2 for initial and final time, being 0 and 6.2 seconds. All right. So there we go. Step 1. Step 2. Step 3, write down any equations that you know of that might help you solve the problem. Well, from my reading, I saw that the average acceleration over a time interval is equal to the object's change in velocity over change in time. These little triangles, of course, being the Greek letter delta, meaning change in, right? Delta means change in, or airplanes that are always late. I'm just kidding. I've never been on a Delta flight that's late. But anyway, So delta V, meaning V2 minus V1 over T2 minus T1 there, okay? So change in always means final minus initial. Now, whenever you use an equation in physics, you got to make sure all your units are the same throughout the equation. For instance, velocity here, I have a time down here in seconds and a velocity here in hours. And the problem does state that I want my final answer to be in meters per second per second. So I'm going to have to take a little sidestep here and convert some units here. So if I have 95 kilometers per 1 hour, might be time for a little dimensional analysis here. And of course, after last night's homework, you guys are all experts on dimensional analysis. So I see that kilometers are going to cancel. So I have meters, which I want. And then in 1 hour, there are 60 minutes. And in 1 minute, 60 seconds. All right. And double checking here. My units cancel. Kilometers cancels. Hours cancel. And minutes cancel. And I'm left with meters per second, which is what I want. So type that into the old calculator there, and I get 26.4 meters per second is my V2 in units that work for me. So I'm going to plug that in up here for V2. 26.4 minus V1 is 0, divided by 6.2 minus 0. And I get, if I divide this out to the correct number of significant figures, which is 2, 4.3 meters per second squared, or meters per second up top per second. All right, so sometimes we just say that meters per second squared. So I have written out my equations, I've shown any algebra that I need to, and I have my final answer there with units for this problem. So this car accelerated at an average rate of 4.3 meters per second, meaning after the first second, the car was going 4.3 meters per second. After the second second, it would be going 8.6 meters per second. After the third second, 12.9 meters per second, etc., etc. Okay? So sometimes at the end of my videos, as a reward for your attention and great work, I reward you with some endorphins by telling a really funny joke. Not always, but sometimes. And for my joke today, I'm going to tell you this one. So a termite walks into a bar, right? And the termite says, "Hey, is the bartender here?" Little double meaning, right? Right meaning, is the guy who serves me my drink here? And also asking, "Hey, is the wood that makes up the bar soft? Because, I like a soft wood to chew through because I'm a termite, and that's what I do." I didn't say the jokes were always funny, but anyway, nice work, AP Physics students. Make sure you do your reading, know your terms there for Section 2.1, and we will see you tomorrow. Take care.